Welcome to this deep dive into browsing security. This is episode 7, and today we're really getting into the weeds on Security Service Edge, or SSE.
That's right.
We've been looking closely at the latest LayerX report, Reevaluating SSE, a technical gap analysis of last mile protection. And it brings up some, well, pretty critical questions for anyone in a security leadership role. CISOs, architects, IT leaders listening in.
Absolutely. SSE is, foundational for many organizations now, especially with distributed workforces. But this report really highlights some, let's call them blind spots.
Yeah, blind spots. Particularly where the user actually interacts with the web inside the browser. That's the last mile they talk about.
Exactly. And our aim here isn't to bash SSE, but to look beyond the glossy marketing sheets and understand technically where it might be falling short for you.
Right. So we'll break this down. First, we'll look at the underlying architecture. Where are the inherent gaps?
And then we'll shift to specific security use cases, GenAI, SaaS data, shadow IT, and see how those architectural limits play out in the real world.
And the main thing we want you, the listener, to take away is this. SSE alone might not be enough. You often need something more, something working right there in the browser for truly robust security.
Couldn't agree more. So let's start with those architectural gaps. The report kicks off by challenging the idea that SSE deployment is, frictionless.
Yeah, that frictionless claim. It sounds great, but the report points out the reality is often quite different.
It really is. For security architects, integrating SSE isn't just flipping a switch. You've got cloud gateways, policy points. They all need to mesh with your existing security standards, compliance rules, identity systems.
It's not a simple lift and shift, is it?
Not at all. The report details considerable integration work.
And a huge piece of that, which the report really emphasizes, is dealing with encrypted traffic. SSLTLS inspection.
Oh, absolutely. That's a constant tightrope walk, isn't it? You need to inspect for threats, but you're balancing that against performance hits, privacy concerns, the whole user experience.
Right, you can't always inspect everything.
Precisely. And the report is clear. Teams often have to make compromises. Maybe they skip inspection for certain sites due to performance or compliance, and boom, you've got a visibility gap right there.
Makes sense. And what about plugging SSE into the rest of the security stack? Legacy networks, SIEM, IDPs, endpoint tools.
Well, the report points out that's another area where it's not always seamless. These integrations often need custom work, specific configurations, and then, ongoing care and feeding. It adds up.
And then there's just the sheer complexity of managing the policies themselves, right? Across all these different cloud services and web apps people are using.
Yeah, policy sprawl is a real risk the report touches on. Maintaining granular, consistent rules across such a diverse landscape takes significant effort.
So what happens when things go wrong? False positives, negatives.
That's another resource drain highlighted in the report. Troubleshooting those, figuring out what's real and what's not, eats up valuable time for the security team.
Okay, so summing up this deployment piece. The report suggests the reality involves more cost, more operational effort, potential performance issues for users,
Potential access disruptions if things are misconfigured.
and potentially longer timelines to actually get it all working smoothly than initially expected.
Exactly. The report indicates that the promise of simplification can get bogged down in these practical implementation hurdles.
All right, let's pivot to another core architectural point from the report. Latency. There's this idea that cloud means low latency, but SSE, maybe not always.
Yeah, the LayerX analysis really pushes back on that assumption. Latency is definitely still a factor you need to consider carefully with SSE.
And the main reason, according to the report, is that fundamental architecture, routing traffic through central points.
That's the crux of it. Sending everything through those centralized cloud gateways or points of presence POPs inevitably adds some delay. It's just physics, distance.
And it's not just the travel time, is it? The report mentions the security processes themselves add time.
Correct. Deep packet inspection, decrypting that SSL/TLS traffic we talked about, malware scanning, DLP checks, authentication steps, each one adds a little bit of latency. And the report highlights how this gets worse the further your users are from the nearest POPy. Think remote workers or people in regions with less developed internet infrastructure.
Plus network congestion, bandwidth limits. They all play a role too.
They certainly do. The report actually gives some numbers. Typical latency increases seen by organizations using SSE range from maybe 20 milliseconds up to over 100 milliseconds.
Okay, 20 to 100 milliseconds. It might not sound like a lot for browsing a static page, but for some applications.
Exactly. That's where the report draws the connection. For things that need real-time interaction, VoIP calls, virtual desktops, collaboration tools like Teams or Slack, even those seemingly small delays can degrade the experience noticeably. Users feel that.
Right, that makes sense. Okay, let's move on to visibility. What can SSE actually see when it comes to user activity? The report suggests there are inherent limits here.
There are.
Yeah.
And this is a really critical limitation the report unpacks. Because SSE operates mainly by looking at network traffic flowing through those central points. It fundamentally lacks deep insight into what a user's doing within their actual browser session.
So it sees the traffic going to and from the website, but not the clicks and typing happening on the page itself.
Pretty much. Its view relies heavily on inspecting that network traffic, and as we said, that often depends on decrypting SSL/TLS at the gateway.
And if you're not decrypting everything for performance, compliance, maybe certificate pinning issues the report mentioned,
Then your visibility into those encrypted sessions plummets. The report is very direct here. Incomplete SSL inspection means you can't see granular actions like file uploads, downloads, form fills. What sensitive data is being typed into fields within those web apps?
Big blind spots then.
Huge. And the report adds another layer. It's not just about encryption. Modern web apps are complex. They use dynamic JavaScript, AJAX calls. Things are happening constantly within the browser page itself.
Like trying to follow a complex play by just watching players run on and off the field.
That's a great analogy. Network-level inspection struggles to capture that detailed event-driven activity inside the application. And the consequence, as the report stresses, is that you can miss vital clues, signs of compromise, data being moved inappropriately, risky user actions.
And the report suggests looking at endpoint solutions to get that browser-level view.
Yes, it points towards things like secure enterprise browsers or specific browser security extensions as ways to complement SSE and gain that missing visibility.
Okay, interesting. That brings us neatly to integrements. SSE vendors talk a lot about integrating with thousands of SaaS apps, but the report paints a slightly different picture.
It does present a more, let's say, nuanced view. The LayerX analysis finds that while, yes, integrations exist, they often depend on the SaaS vendors providing really solid, standardized APIs.
And not all of them do.
Exactly. The report notes that really deep, robust integration is often limited to the major, most popular SaaS platforms. Many other tools, especially newer ones or niche apps or a lot of the GenAI tools popping up, they just don't have those rich APIs needed for seamless SSE control.
And even among the ones that do integrate, the report suggests the level of control isn't always consistent.
That's another key finding. You might get full policy enforcement and detailed logs for, say, Microsoft 365, but maybe only basic monitoring for another integrated app. It varies a lot.
So it's not a uniform level of protection across your SaaS landscape?
Far from it. And the report underscores that setting up each integration takes work, custom configs, specific policies, ongoing upkeep. The result can be this kind of fragmented ecosystem, inconsistent visibility, gaps in policy enforcement, and a big administrative headache for the security team.
Right. Okay, what about protecting users who aren't on the corporate network? Remote workers, mobile users, the report flags challenges there too.
Yes. Securing the off-network user is inherently tricky for SSE. The standard approach involves routing their traffic back through those central cloud gateways.
Usually via VPN or maybe a proxy or an agent on the device.
Exactly. But as the report details, that introduces the latency issues we already discussed, and sometimes connectivity problems too. It can impact productivity.
And can users just bypass it if they're on their home network, maybe using a personal device?
That's a major concern highlighted in the report. Ensuring consistent policy enforcement when you don't fully control the device or the network is really difficult. Users might connect directly, completely bypassing the SSE controls.
Leaving them exposed.
Precisely. And the report adds another risk here. Endpoint threats. Things like malicious browser extensions, maybe unauthorized software installed locally. Network inspection from an SSE gateway can't see or stop those. They operate below the SSE's radar.
Okay, so pulling all these architectural points together, the LayerX report seems to be saying the fundamental limitation of SSE is its reliance on network-level inspection.
That's the core argument, yes.
It lacks that fine-grained control at the very endpoint, the last mile, where the user is actually interacting within their browser.
Exactly. The report concludes this leads to critical gaps. It gives examples like SSE struggling to prevent data being copied and pasted from a secure app to, say, personal email, or a GenAI tool.
Or managing file uploads and downloads when there's client-side encryption involved?
Right. Or dealing effectively with those potentially risky browser extensions installed locally. SSE just doesn't have visibility or control there.
And what about things like enforcing specific login controls within a website?
But also very limited, according to the report. Because SSE typically can't intercept those client-side authentication flows happening inside the browser page, it can't enforce really granular access rules within the site itself.
So the bottom line from the report on architecture seems to be blind spots for data leaks, unauthorized user actions, shadow sauce use, malicious extensions.
All stemming from that lack of last-mile control, which is why the report strongly suggests looking at complementary solutions that do operate at the endpoint or browser level.
Okay, that provides a really clear picture of the architectural limitations. Now let's dive into part 2 of the LayerX report, looking at how these gaps show up in specific security scenarios. First up, preventing data leakage into GenAI tools. That's a hot topic.
Extremely hot. And the report identifies several reasons why SSE alone struggles here. One big issue is just controlling access to all the different GenAI sites popping up.
Because they can appear quickly, maybe use shared hosting, so just blocking domains isn't enough.
It's often ineffective, yeah. Domain-based blocking struggles to keep up. And even if you allow access to a specific GenAI platform, say ChatGPT or Gemini, the report points out that SSE typically can't tell if the user is logged in with their corporate account or their personal one.
So you can't enforce different policies based on the identity context.
Usually not reliably at the SSE level. And then there's the fundamental issue, as the LayerX analysis stresses. SSE, being network-based, generally can't see the actual prompts or data being typed or pasted into the GenAI interface.
Even with SSL decryption.
Often not, or not reliably. That interaction is happening within the encrypted session, within the browser's rendering of the page.
And crucially, that lack of last-mile control means SSE can't easily stop someone from, say, copying sensitive code or customer data and pasting it right into the AI prompt box.
Exactly. That action happens entirely client-side within the browser. It bypasses network controls. So the report's conclusion here is pretty stark. Relies solely on SSE, and you've got a significant risk of sensitive data leaking into external AI models, accidentally or deliberately.
Okay. Moving to general web and SaaS data protection DLP, the report says SSE DLP has limits too.
It does. The LayerX report clarifies that SSE DLP typically works at the network or proxy level. So it's mainly looking at files being uploaded or downloaded through that monitored network path.
Which means if a SaaS app isn't fully integrated or doesn't have APIs for data control,
your DLP enforcement might be limited or non-existent for that app. It creates gaps, especially beyond the major, well-integrated platforms.
And the report really hammers on the issue of fileless data movement within the browser, doesn't it?
Yes, that's a key vulnerability it highlights. Things like copying text from a Salesforce record and pasting it into a personal webmail client, or dragging and dropping data between browser windows, or even just taking screenshots.
Actions that don't involve uploading a distinct file.
Exactly. And because these happen within the browser session, the report states clearly that network-level SSE DLP is largely blind to them. Users can exfiltrate data this way without triggering alerts.
Which has serious implications for compliance, data breach risk, insider threats.
Absolutely. The report underscores these risks in today's browser-centric work environment.
Okay, let's talk shadow sauce, those unsanctioned apps users adopt. How does SSE handle discovery and control there, according to the report?
Well, the report suggests it's another area with significant limitations. For one, shadow sauce is often accessed from unmanaged devices or personal browser profiles, completely bypassing any corporate SSE.
Right. If the traffic doesn't go through the SSE, it can't see it.
Precisely. And even on managed devices, SSE relies on recognizing known applications, usually through domain lists or signatures. It struggles to identify brand new or obscure services that aren't in its catalog yet.
And again, that last-mile control issue comes up, like blocking uploads to a specific shadow app.
Yes, the report reiterates that enforcing granular actions within these shadow apps, blocking uploads, preventing copy-paste, controlling OETH grants, is typically beyond SSE's capabilities operating at the network layer.
Because the integrations are limited or inconsistent?
Partly that, and partly the fundamental network-centric approach. Plus, the report revisits the difficulty of distinguishing corporate versus personal accounts accessing the same platform, making consistent policy enforcement hard.
So the takeaway on shadow sauce is similar.
Very similar. The report concludes that effective discovery and control really need capabilities operating closer to the user endpoint or browser-native solutions that can see and act upon activity within the application layer itself.
What about identity security and governance? SSEs integrate with SSO, right? But the report suggests there are still gaps.
There are. While SSE does a good job enforcing access via corporate SSO for sanctioned federated apps, the report points out its visibility drops off sharply elsewhere.
Like for apps not using SSO, or when users use non-corporate accounts.
Exactly. If an app isn't integrated with your SSO, or if a user logs into a corporate resource using personal credentials, if that's somehow possible, SSE often can't see or control that. The report emphasizes SSE can't really monitor the authentication flows happening inside the browser page.
So personal Gmail accessing a corporate Google Drive link, for example, SSE might miss that.
It very well might, depending on the setup. And the report also notes that core identity governance functions managing password policies, MFA enforcement beyond the initial SSO login, identity lifecycle, those aren't native SSE capabilities. You rely on your external IDP for that.
Creating a sort of fragmented control plane.
That's the concern the report raises. Also, even SSO enforcement might not be absolute. If direct logins to SaaS apps are still possible, users might bypass SSO, and SSE might not prevent that.
And what about attacks after authentication? Session hijacking, credential stuffing attempts?
The report highlights that SSE generally lacks visibility into those threats occurring at the browser or application layer. They happen post-authentication, often exploiting session cookies or weak credentials reused elsewhere.
So the risk here is unauthorized access, data exposure, compliance issues, all stemming from identity blind spots, even with SSE in place.
That's the significant risk the report underscores for cloud environments.
Okay, let's look at web vulnerabilities and phishing. SSEs have secure web gateways, cloud firewalls, but the report says they're not foolproof.
No, the LayerX analysis points out critical limitations here too. A key issue is, again, that lack of deep visibility into the user's actual browser session. SSE relies heavily on network signals like domain reputation.
Which attackers can sometimes bypass.
Definitely. They can use compromised but legitimate domains or host malicious content on file-sharing sites. The report gives examples like zero-day exploits targeting browser components, malicious scripts hidden on seemingly okay websites, threats embedded in iframes.
Things that might look benign at the network level, but are malicious once rendered in the browser.
Exactly. These exploit activities happening within the session. The report concludes that these blind spots mean SSE isn't sufficient on its own against modern, sophisticated browser-based attacks.
And finally, the report calls out malicious browser extensions as a particularly worrying blind spot.
Yes, this is highlighted as a major area of concern. The report states very clearly, network-based SSE has practically no visibility into browser extensions.
It can't see what's installed, what permissions they have, how they're behaving.
None of that. That information resides locally within the browser. And the report emphasizes SSE also can't typically prevent users from installing new extensions. That's usually governed by browser settings or endpoint policies, not the network gateway.
And the really scary part the report mentions is that SSE can't reliably detect or block the communications from these extensions.
That's the critical failure point. If a malicious extension is sending data out, maybe beaconing to a C2 server, posting stolen credentials, exfiltrating data, it can often do so using encrypted channels or techniques like domain fronting that evade network inspection.
So these extensions can act like hidden spies inside the browser.
Essentially, yes. The report concludes they can be persistent, invisible data leakage channels operating completely outside the reach of traditional SSE controls.
Wow, so pulling part two together, the LayerX report paints a picture where, as more work moves into the browser, SSE alone really struggles with key risks. GenAI leaks, SaaS data exposure, shadow IT, identity issues, web threats, and especially extensions.
That's the clear message. Despite the goal of unified protection, SSE's network-centric design means its effectiveness really breaks down for these specific, high-impact use cases that hinge on browser-level activity and context.
The report includes a summary table that makes these gaps very explicit across each use case. It's quite compelling.
It really drives the point home.
So, given this detailed analysis of the limitations, what's the path forward? What does the LayerX report recommend?
The core recommendation is straightforward. You need to augment SSE. Specifically, the report argues for implementing security controls that operate directly within the browser environment to address those last-mile gaps.
And it points to things like secure enterprise browsers or enterprise browser extensions.
Exactly. Those are presented as the key technologies bridge the gap. The report emphasizes their unique advantage: unmatched visibility and control over what's happening inside the user's browsing session.
The very things SSE struggles with: copy-paste, form fill, shadow sauce interactions, credential use, GenAI input.
Precisely. Where SSE is hampered by encryption or lack of endpoint visibility, the report positions these browser-level tools, either a dedicated secure browser or an extension enhancing an existing one, as having direct insight and control.
And they can provide real-time enforcement, blocking risky actions as they happen.
That's the idea. The report highlights their ability to offer identity-aware, context-sensitive controls right where the action is, blocking a copy-paste of sensitive data, preventing login with a personal account, stopping an upload to an unsanctioned site, all in real time within the browser.
And the report also mentions an advantage regarding latency and complexity.
Yes, because these controls run locally, they typically don't introduce the network latency associated with routing traffic through a central SSE gateway. The report suggests this makes them a less frictional, more user-friendly approach, especially for remote and hybrid teams.
So the conclusion is, adding browser-level security isn't just nice to have, it's becoming strategically necessary.
That's the strong conclusion from the LayerX report. It's essential for comprehensive security in today's browser-first enterprise.
Which, logically, brings us to LayerX itself. The report positions LayerX as a platform designed to fill exactly these gaps.
It does. It's presented as an agentless security solution, delivered as an enterprise browser extension, aimed squarely at mitigating risks across GenAI, SaaS, web browsing, identity, and data leakage, crucially, without negatively impacting the user experience.
And the report lists specific capabilities, like managing browser extensions.
Yes, discovering installed extensions, assessing their risk, blocking dangerous ones. Also, specific GenAI security features, mapping usage, finding shadow AI, restricting data sharing.
What else?
Comprehensive web and SaaS DLP, zero-hour protection against web threats by analyzing code in real time, shadow sauce discovery and control, identity protection features like preventing account takeover or use of risky identities, and securing access for BYOD and contractors.
So the key benefits highlighted in the report are achieving that crucial last-mile control, having granular policy options, and doing it all without making users frustrated.
That's the value proposition outlined. And the report specifically directs listeners interested in tackling GenAI data leakage without killing productivity to check out the LayerX website, layerxsecurity.com, to book a demo.
Okay, so wrapping up this deep dive based on the LayerX report, the takeaway seems clear. SSE is important, it's a key part of the puzzle, but it's not the whole puzzle.
Not anymore. Not with how threats have evolved and how much critical work happens inside the browser.
That last mile of user interaction requires specific browser-level visibility and control that network-centric solutions inherently lack. Thinking about browser security is no longer optional.
It really seems to be a critical component of any modern defense-in-depth strategy.
Absolutely. Well, thanks for digging into that report with us. Lots to think about for our listeners.